Right, hello all and welcome to this video lecture about Octave with Spice, and we are now in the Spicy chapter of the More Deep Bakery, and we have now more or less we have modeled the problem as an LP and found out the metrics representation of it, basically with data being C and technology matrix A and resources B, and then found out that this is the kind of spell we have to write to the GLPK so that it will solve it. And okay, let's do this. And I already actually have the solution here in a script file, so let us download the script file. So you can just click it here. All right, and now for me it opens the Firefox and then save file. All right, let me do it. And then again, this is always a bit annoying to do it, but maybe I should do it again, since this is where you easily make a mistake. So it's downloaded, and for me, for some reason, I don't know why, the Firefox doesn't ask where it should be downloaded. It goes to my directory down. Of course, I could set up it differently, and there it is. For you, it maybe goes to the folder downloads, or depending on the system, maybe it asks for it. In any case, I have to move this to the actual folder that I'm going to use in Octave. So I here ask it move to, and my folder is, okay, I have a shortcut here, it's spicy OR, and I should select, and so it moves it there. Actually, I don't do it because I already have it there for obvious reasons, but you should do that. So you should make sure that the file is downloaded and moved, or if it doesn't go there automatically, to the Octave folder that you are going to use. So what does this mean? Well, let us start Octave, which is, I still have it open here. Let me close it and open again. Again, a good idea to do this every now and then. At least this way, some clutter that may be there because you have been working with it is removed. Okay, now we start again. And when you start Octave, maybe this is the good thing to first check that if your current directory is the one that you wish it to be. So me, it's /home/t-sottinen, which is my home directory. This is not the one that I want it to be. Instead, I want it to be in my work, teaching, and spicy OR called directory. So I choose it to be that. Sorry. And there, let me start actually the editor here. Or let's just first try out if it works. So I should, if I just type more deep, because it's the script file called moredeep.m, so this should actually solve our problem. Okay, I get something. Let's look at this something later. This was just to check that the file is actually there and it's working. So now let us go to the file. I open this moredeep.m here. Let me put the font a little bit bigger. And let us now explain how this works. So what happens now, I will explain it here using this Octave window. I will say, probably in slightly different words, what is going on here in this, well, 4.8 solution More Deep Bakery. So here there is the list here, which is basically, well, not basically, it's exactly the contents of that file, and then there are line by line, more or less line by line explanation what's going on. You should definitely read that, and if you have any questions, please ask me. What happens now, I will go through the same thing with this the same code here, and of course maybe I will use slightly different explanation, different words. Let's hope that this benefits you. Okay, so what do we have here? We have, of course, as always, here is the beginning. There is some kind of title block, so it's commented, so Octave doesn't care about what is here. This is just for the human reader, so you would know what is this file all about. So this is the more deep bakery, and then the reference here. This is the problem 4.1 from Octave with Spice. Okay, there you just put the title basically. Then, well, this empty line just to break the block. Octave doesn't care about it. Then the rest goes. Let's look at the top view first. So it's, I think this is good practice. So we have the problem data. It's basically this block here. Then we have the beef, so to say, so the actual calculations. So it's the block here, which is rather short now. And finally, there is the block where I asked for the output. So the idea is that all the previous ones are edited with semicolons. I don't ask the output there. It's given in a different block. And then there is a new thing that we haven't had before. This is the kind of test result. So what is here, this is basically for yours and of course for my convenience also. So here I just, you see, this is the command prompt of the console or command window. And then I test the more deep and I looked at the output, what was there. So basically it's the same as happened here. And I put it there in the comments. So this is for test purposes. So you should of course run this file yourself and see that if you get the same results, good. If not, then something went wrong either with you or with me or with both. Okay, so this is a good practice also sometimes to have the test results or the results commented there for, well, debugging purposes basically. All right, let's then go to this data. So how it's given here. So we have C, A and B, we know that now. So the three ingredients basically. We need to tell the GLPK in order to solve the LP, because our LP is basically relatively standard form. Let's actually have it here in the previous section. So we actually, I think this is the remark 4.4, more deep LP with matrices. This is the one that's important now. So there we found out what is a C, what is a and what is a B, and then with those our more deep bakery LP is actually this problem. So we have to tell C, A and B basically, and that is of course precisely what we are going to do. And here again comment line says, so C is the prices for Atreides, Corrino and Harkonnen. So C equals 120, 170, 100, and again it's a column vector. That's why there is this single quote or prime. I think it's actually not necessary, but it's better to have it there and not. Semicolon, we want Octave to be quiet. Then there is this technology matrix, so nutrient powder decomposition of cakes of Atreides, Corrino and Harkonnen. So again here a comment line to tell us, so we remember next week also what is happening here. So it's good to use more comments than less comments. Believe me, you will forget otherwise what you were trying to calculate there. And the same thing here about these comments. So each of the lines, because these correspond to some constraints. So I have these comments, and so the constraints are related to fat powder, sugar powder, protein powder, water powder, and spice melange powder. and then I also given there what are the units, since the units are for different constraints, they are different units. So the first three constraints are in grams, fourth one water powder is in milligrams, milliliters, and the spice melange is in milligrams. Okay, it doesn't matter, they can be in different units for different rows, different constraints. Of course, within the constraint there has to be the same units. Alright, here is the matrix A. This is what we have know already how it was constructed. Maybe a minor point here, this is something new we haven't seen yet. So you notice that I have written this now in a nice aligned form so that the rows and columns are easy to read. So this is possible, and this is one reason to use script files. If you try to do this in console, it's in principle possible, but I wouldn't try it. And here again to note that these semicolons meet the end of the row for a matrix, and this semicolon here has a slightly different meaning. The meaning here is again this, please be quiet. Alright. Then what is left here in the data section is the B, so the available nutrients, and then I here made a note of the scale. So these were the available nutrients we had. B for 100 kilograms, 400 kilograms, 150 kilograms, 300 liters, and 10 grams actually. Well, it so happens that all of these units were the 1000 times of these units respectively. Well, it wasn't a coincidence, I did it this on purpose. So to make the unit change so that units in B correspond to these units, I had to just multiply each of the component by 1000. So that was the kilo means, or milli means 1/1000. So this can be of course done in a simple, this you learn probably from linear algebra, that if you multiply a vector by a number, then it means that each component is multiplied by this number. So that's it. That's the data section. C, A, and B are given there, and then hopefully if we just want to change C and A and B, we can change them there, and everything rest works the same way, so we don't have to worry about that. Unfortunately, this is not going to be completely true. Okay, why not? So let's see this solution with GLPK. So this we had at the last video also, so let's see what happens here. We only ask two output parameters, X max, so this is the optimal decision, and then Z max, which will be the optimal revenue we get with this optimal decision. So there could be this error number extra and so on. Let's not worry about them at the moment. Then this equals, so we call the GLPK, and let's see how this works. So always we have the C, A, and B. So objective function C, technology matrix A, available resources B. Okay, they were given just here. Good. And this is something that you will see a lot in this course, couple of empty matrices, because the next ones were the lower bounds and upper bounds for the decision variables x's. So the lower bounds were by default the sign constraints, that is they must be positive. Well, we have it, so we use default, that is we don't give it. Upper bounds, we don't have upper bounds as such. Of course there are some upper bounds induced by B, but we don't have a priori upper bounds, if you like, for the x's. So this is empty also, so this is also empty matrix. And what then? Then we have to give the C type, constraint type. So we have to tell in what sense are these constraints related to fat, sugar, protein, spice, and water and spice melange, how they are related to this technology matrix. Well, they are the available resources, so they are upper bounds. Okay, so that's for you, and there are 1, 2, 3, 4, 5 of them. excluding the sign constraints. They don't come here. They were basically this one. They are always there. So this is 5 U's, and it's note that it's not like this. This would mean that the value here would be the value of the variable that is U capital, U capital, U capital, U capital, U capital. I could have a variable with that name. No, it's not that. It's the literal string with these U's, and the color encoding helps you to understand that these are different things. So that's why it's within quotes. Those are double quotes. You could use simple quotes like this also. That's the same thing. It's just a matter of taste. I always use double quotes for no reason really. Just use them. Then the next one is the constraint type. Sorry, not constraint type, but decision variable type, var type. So we have to tell what kind of variables these x1 and x2 and x3 that are for this Atreides, Gordon and Harkonnen. Well, there are 2 possibilities. Either they are integers or they are continuous. Continuous meaning something like real numbers. And in this course, although this is a subtle point, we will discuss this a little bit later, but unless otherwise stated, let us assume that everything is continuous. I mean, world is so much better when everything is continuous. I mean, integers are nasty things. Real numbers are much nicer. You wouldn't believe it, but it's true. So there are 3 variables and they are all continuous. So this is a literal string of C, C, and C. And finally, I have to tell that this is actually a maximization, because for some strange reason GLPK developers chose that the minimization is the default and the maximization is the alternative. I like to think the other way around. So this is not 1, but -1 -1 really means that it's a maximization. And that's it. And then finally here, since I just asked, I type the name of the variable. This means that then Octave will echo back the value of this variable. So this is where the output happens. And then just again finally we have a new thing we haven't had before. So test result. So what happens here is that, well, if you look, if I uncomment this, then this would mean that I'll just or actually copy this to the command window. This means I call this, so it means precisely what happened here, and then I just copy pasted this and commented here in the editor. So this is just for you, so you can check that this is the solution I got. I hope you got the same solution, and if it's not the same, then at least one of us has made a mistake, obviously. So that's about this. Maybe a final thing, this is, I tried to be elegant, so you should compare this with the net present value elegant solution. And the idea is that you can just change this data section, and you don't have to change anything here, and it will work just fine. Unfortunately, this is not completely true here. The reason is that, of course, C, A, and B are just variables here that can be set here. If I change C, A, and B, there's nothing, no problems up to here. These are also empty matrices, there are no problems up to here. But this and this will be minor problems with a hiccup. So if I add or remove constraints here, I have to add or remove here the number of these U's. And same for the variables. If I add or remove the number of variables, which means here the columns of C or A, then I have to add or remove C's here. Okay. It is actually possible to do it, so it's not too difficult, but it's possible to do it in the data section. This C-type and this var type are set to be the correct ones, so that it will work so that we can change C's, A's and B's and as we like, and everything works just fine. I decided not to do it here because I thought that it would be a bit too much at once. So, and sometimes it, although it pays to be elegant, and it's good to be elegant and make everything generic so that it works, so that you don't have to tweak too many places. But I mean, there is a limit to the elegance also, so maybe you shouldn't try to be too general. There is something like a golden path somewhere in the middle. Okay, so that was the explanation of the code. I hope that this helped, and I hope that, let's get back to the notes, that that it will complement the explanation that I've given here. Finally, of course, the solution here, it's yeah, as I said, Xmax is that you will do the more deep bakery should bake something like 172 Atreides cakes and 246.5 something Corino cakes and no Harkonnen cakes at all. Okay. And yeah, that's the solution. Now you could think, let's analyze it and so on, see what happens if something changes. Why is it that we don't make any Harkonnen cakes at all, and so on. And indeed, this is something that we shall do later, but at this point, let's just be happy with this solution. All right. Sorry, I had to check. Yes. So, the end, or so to say, the end of the main part of this Octave with Spice is exercises, and then we will have still one more video lecture related to this chapter. But let's discuss a little bit of exercises here in the end. So we have an exercise 2.9 here. This is a LP with no story. So the idea here is simply that further get some exercise how to do the GLPK. So this is just an LP given this way. I didn't bother to, or I didn't want to confuse you too much to have a long and elaborate story how this, where this comes from. This doesn't come from anywhere actually. I just made a LP. So you should solve with GLPK something like this. This is, you should of course look for hints above in the notes. What are the couple of things here that are different from this more deep LP? Well, there are actually 4 variables, x1, x2, x3 and x4, but they are not all present in all of these lines. So what do you do with that? Well, probably it's not too difficult to figure out how to do that. And then, okay, about the B's here, so some of these constraints are upper bounds, some are lower bounds, and some are actually equalities. So these are the 2 changes for this more deep problem that was standard for. I think this is relatively straightforward, but of course it will take some time for you to figure out how this should be done, and for that you should of course consult the help listing of the GLPK. Okay, then exercise 4.10, limited Atreides and part 2. Okay, we had exercise 4.6 was limited Atreides part 1. Well, obviously this part 2. This should be relatively simple. So there in part 1 you were asked to model this as an LP, and now you are asked to to solve the LP with GLPK. And exercise 4.11, Harkonnen promise, part 2. Obviously a similar thing that was in part 1. In part 1 you were asked to consider this LP or construct the LP, and once you have constructed the LP, I think it should be straightforward to solve it with the GLPK. So that's pretty much the end of the main story so far about LPs and how to solve them with GLPK. We will have still one video section, video lecture of this chapter, but that's, certainly I encourage you to watch it, but this is something that's, I would say maybe at this point, something that if you are confused about it and don't get everything, it's not a problem, because we will come back to those things later. In any case, at this point, I bid you farewell, and let us see in the next video lecture. Bye bye.